If your company is running Dev, QA, and POC environment 24 by 7 on AWS, you are burning money. Most teams pay for idle infrastructure that runs overnight, over weekends, and sometimes for months for a project ends. I will show you how to eliminate waste entity, spin up full Kubernetes cluster with monitoring in under 2 minutes, use it and destroy it when you are done. Your dev environment build drops by 60%. Let's build it. Let me first show you the three situations where this saves your serious money. Use case number one, dev environment. Your developers need a Kubernetes environment. They only need it during working hours, 9 to 6, Monday to Friday. With this setup, they click one button in morning. Cluster is live in 2 minutes. End of the day, one click, everything is gone. If we do this, that is a 60% saving. Now we will talk about the second use case, POC environment. Your team needs to do a proof of concept, spin up a full stack, deploy the application, run the demo, show the stakeholder the live Grafana dashboard, then destroy everything. No lingering infrastructure, no forgotten EC2 instances. Use case number three, functional QA environments. QA test needs an environment only during a test run. Spin it up before testing starts, capture the results, destroy it when done. I want to be honest here. This setup is perfect for functional testing, for performance testing, and high availability variation. High availability validation, you need dedicated persistence infrastructure. But for QA environment, this is really good. You can save up to 60% of environment cost. These are the three use cases, and I have built pipeline for it. Let me show you how it works.
Okay, this is the complete flow. Let me walk through it step by step. Our automation engine based on Jenkins. When anyone click builds now, Jenkins triggers the entire pipeline. The first thing Jenkins does is run Terraform. Terraform provision two EC2 instances in cloud, one master, the other one is worker node. These are the compute resources used by Kubernetes to run our cluster on it. Once the instances are up, our post-provisioning script runs automatically and it SSH into the master node and install Kubernetes cluster. That is a lightweight Kubernetes distribution, perfect for dev, QA, and POC environment because it is fast to spin up and use minimal resources. The worker node then join the cluster automatically using Kubernetes token. No manual, no SSH commands, everything is scripted. Finally, Helm deploy monitoring stack, Prometheus stack on the cluster. That gives us Prometheus for the metric selection and Grafana for the visualization. By the time this stage completes, your dashboard is live. For destroy, a simple pipeline is created which calls Terraform destroy, everything gone clean, no orphan resources. Here's Jenkins file. He it is having couple of stages, Terraform init, Terraform validation, plan and apply. Let's see what it does with the Terraform apply. Here I have main.tf. I have configured couple of security groups. I have created the EC2 instances. Here is the template for the EC2 instances. Two instances will get created. One is master, the other one is worker. I have configured Grafana domain as well. Here you can see the subdomain is configured. Coming back to the Jenkins pipeline, once the two instances will get created, it will retrieve the master IP and worker IP for future use. Here you can see it is installing Kubernetes cluster on master. It will retrieve the token and then it will join the worker with the master. So this is the validation of clusters. So yeah, this is the Jenkins files for the first step. And once it is successful, it will call the another pipeline, that is the dashboard. This pipeline is for the Kubernetes dashboard. If user wants to see the Kubernetes dashboard, this is important part of the deployment. The third and last one is for the monitoring stack. It will install the Helm first, and then it will deploy the monitoring stack. And you can see that this is the Cube Prometheus stack, which will deploy Prometheus as well as Grafana. So yeah, that's all. This code is in the GitHub, and you can use it. The link is provided in the description. One more pipeline, that is the Jenkins destroy. It will call Terraform destroy to destroy all the resources which were created. Now I'm on my AWS console, so you can see only one Jenkins server is running at present. And here is my Jenkins pipeline to provision the setup. I'm going to build now. Okay, the build is started. Here we can see the logs. Okay, it is initializing the Terraform init, and in here also we can see the stages, what is going on. So Terraform init is completed. Now Terraform validation is going on. So as it is not yet applied, nothing is provisioned here. So now it is the plan. It will see what and all resources it is going to create. So everything will get listed here. It will auto approve for the apply. Elastic IP and configure the Route 53. It is creating EC2 instances. Go back to our console, refresh it. Let's see a master and yeah, it is. These two are just now provisioned. These are in initializing stage, so it will take some time to come up. Okay, it retrieved the IP address for the master worker and it will SSH, and then it will deploy the Kubernetes cluster. It is just finding the available Kubernetes cluster version. The cluster is deployed. It got the token, and now it is joining the worker node. We can add as many as worker node we want to join with master. Here, the first pipeline is completed. It will schedule the second one, that is for the Kubernetes dashboard. Let's see whether that pipeline is triggered automatically. Yeah, so you can see here is the Kubernetes dashboard triggered. It will deploy the Kubernetes dashboard. Okay, this is done. Now the last one, that is for the monitoring part. So this is also, it is triggered automatically, and it will deploy the monitoring stack, Prometheus plus Grafana. So this is okay. It is okay, done. See, pretty quick. So monitoring is successfully deployed. Now we'll go to Grafana dashboard and we'll see the Grafana dashboard is up and running. Oh yeah, it is up. So let's log in. This is not best practice as this is a demo. That's why I just print the password. Okay, here we can see all the required pods and if worker node is there, so this is that's it. Like this is pretty quick. Within I think 2 or 3 minutes, we are able to deploy the complete environment, a Kubernetes cluster. On top of that, microservices, Grafana, Prometheus are up and running, and we are able to access the dashboard. Okay, now the final stage of our demo, that is for the Terraform destroy. We do not want to use this environment anymore, so we can destroy the environment. So for that, I do have a separate pipeline, that is uninstall monitoring. So once the monitoring is uninstalled, uh, then we can destroy the infrastructure. We can run this pipeline. So this will remove all the resources which were created for this demo. So it is simple, like whenever you want to use the environment, see, it is only 2 minutes. So if you have your microservices on GitHub, then you can deploy your services on the cluster using pipeline or any other tool, and you can test it. You can do further deployments. You can use this environment for a specific time period. So it is destroying all the resources, all the created resources. Let me see the console. I will remove this running. Okay, so here it is removing the resources. What we did, we run the pipeline to create the infrastructure in the AWS cloud, then deployment of Kubernetes cluster. Then on top of that, we deployed monitoring stack. Once we are done with the demo, we uninstall the application and we destroy the application. We destroyed the infrastructure using destroy pipeline.
The full code, Terraform, Jenkins files, Helm values, post installation scripts, everything is on GitHub. Link is in the description. Go clone it, adopt it for your environment, and start saving money this week. If you want this build for your team or startup, end-to-end production ready, customized to your requirement. This is exactly what we do at CloudBridge Tech Labs. Link is in the description. If you are a test engineer watching this video and thinking you want to move to DevOps, or you just completed your graduation and want to start your career directly in DevOps or cloud engineer, CloudBridge Tech Lab has a mentorship program built specifically for you. We work with you hands on and with real infrastructure, real tools, real projects, exactly like what you just watched. Not a course, not pre recorded video, directly mentorship program from someone who has 20 plus years of experience. Link to know more is in the description. Come build with us. If this video was useful, subscribe. I cover real DevOps solutions, not theory. Every video is a real problem solved with real code. I am Sachin Kumar. See you in next one. Thanks.